Hello, welcome. Today we're going to look at the 2004 FRQ 5 from the AP Calculus AB exam. So we're provided the graph of a function f, and it says the graph consists of a semicircle and 3 line segments. So that's important to understand that this is a semicircle and not some arbitrary curve, because we can apply the formulas for area of a circle when we're finding the area under the curve of that segment. And it also tells us that the function g is defined by g of x equals the integral from -3 to x of f of t with respect to t. So now that we understand what's given and what the question is asking, or not really what the question's asking yet, but we understand what's given and we understand probably the direction this question is going to go in, let's look at A. So first, A asks us to find a g of 0. So all that g of 0 is the value of the function g when x is equal to 0. So let's just plug in the number 0 for x in g of x. So g of 0 is equal to the integral from -3 up to 0 of f of t dt. And the integral from -3 to 0 of f of t is just the area under the curve from -3 to 0 on this graph of f. So let's do that. So that is equal to this portion. I'll go ahead and do this in red. So -3 to 0. And we can split this portion, or this area, into a rectangle and a triangle. So the area of this rectangle is 3, because 1, 2, 3 is its base, times 1. So that'll be 3. Plus the area of this triangle is 1, 2, 3 times 1 divided by 2. So 3 times 1 divided by 2, we can just write 3 over 2. And because it's an FRQ, we can just, this can be our final answer. G of 0 equals 3 plus 3 over 2. But if you had a multiple choice question and this wasn't one of the options, you could obviously convert 3 into 6 over 2 and then add 3 over 2 to get 9 over 2. So now the next part of A asks us, I'll continue A up here. The next part of A asks us to find g prime of 0. So first, before we find g prime of 0, let's find g prime of x so that we can plug in 0. So g prime of x, when we have an integral like this, when it's from a number to a variable, what we do is the derivative of this variable, which in this case it's just x, so the derivative of x is 1, times this, so f of this, so f of x, 1 times f of x. So g prime of x equals f of x, or 1 times f of x. And what that means is if we plug in a number, let's say we plug in -3, the output of g prime of -3 is the same as f of -3. And what f of -3 is equal to is just the output of the function f at x equals -3. So we go to -3 on f, and we see that the output is 2. So g prime of -3 equals 2. So what we can do from here is take this function and plug in 0, because it's asking for g prime of 0. So you go g prime of 0 is equal to f of 0, which is equal to 1. Because on the graph of f, the output at 0 is 1. So there's part A completed. Now that we're done with part A, we can look at part B. And part B asks us to find all of the values of x in the open interval -5 to 4, at which g attains a relative maximum. And it also asks us to justify our answer. So the points at which g attains a relative maximum, g prime, I'll start by writing B. When g is at a relative maximum, g prime is going to be equal to 0, right? The slope of the tangent line at a relative maximum is equal to 0. The slope is 0. So first, we have to find all the points at which g prime is equal to 0. So the way we're going to do that is we're going to go back to our g prime equation. If you recall, you would have it written down on your paper. Obviously, I just erased it for the sake of preserving space. but we found that G prime is equal to F. So G prime of 0, or G prime equals 0, sorry, is the same as F equals 0. And F equals 0 at this point here at -4, so -4, also at 1, and also at 1, 2, 3. So these are all the points where G prime is equal to 0, or where F is equal to 0, because G prime and F are equivalent. So now that we have these x values, or all the x values where G prime equals 0, we have all of our possible points, or possible x values at which G could attain a relative maximum. So now to find if G actually attains a relative maximum at these points, we have to find if G prime changes from positive to negative. So what that means, if G prime is changing from positive to negative, G is changing from increasing to decreasing, right? Increasing to decreasing, and that's what our relative max is, increasing to decreasing. So if G prime is equal to F, then we have to find where F changes from positive to negative. So let's test each of our points. Let's start with -4. So at -4, the graph of F changes from negative to positive. So that means G prime changes from negative to positive, meaning G changes from decreasing to increasing. And that is a relative minimum, which is not what we're looking for. So we can cross out -4. Next, let's try 1. So F equals 1 is right here. Here, F changes from positive to positive, right? It doesn't cross the x-axis. It just stays positive. So that means G prime changes from positive to positive, or G just continues to increase, which is not what we're looking for. That's not a maximum. So we can cross out 1. Finally, let's test 3. So at 3, F changes from positive to negative, meaning G prime changes from positive to negative, meaning G changes from increasing to decreasing, and that is a relative max. That is what we're looking for. So 3 is our final answer, x equals 3. But it's not actually quite our final answer, because it does ask us to justify our answer. So what you'd actually write on your FRQ on your test would be, so it says, where does G attain a relative maximum? So I like to kind of use the words in the question so that you make sure you're answering the right thing. So you can write G attains, wait, let's find the face cam. Let's move that. Go like this. Put it up here. Okay. G attains a relative, you can write relative maximum at, it only asks for the x value, so at x equals 3, since x equals 3 is the only, pretend that's an n, looks more like an h, but is the only point at which, looks like a k, but anyways, is the only point at which G prime changes from positive to negative. So if G prime is changing from positive to negative, or from positive to negative, then G is changing from increasing to decreasing, meaning increasing to decreasing, there's a max at the top. Okay, awesome. B's done. Now let's look at C. So C asks us to find the absolute minimum value of G on the closed interval -5 to 4. So closed interval meaning it includes the endpoints of -5 and 4. And it also asks us, like in the last one, to justify our answer. So I'll change to black here. Let's start with C. So using EVT, or the extreme value theorem, we know that candidates for the absolute minimum value of G are g of -5, let me write this a little neater. We know that candidates for the absolute minimum value of g include g of -5, because we have to include both endpoints, and g of 4, right? Those are the two endpoints. And also wherever g is at a relative minimum. So when g is at a relative minimum, like we were just talking about in the last example, g prime changes from negative to positive this time, not positive to negative, because what that means is that g changes from decreasing to increasing, so that's a relative minimum. And if g prime is equal to f, so we have to find where f changes from negative to positive, because that's where we have a relative minimum on the graph of g. So let's find where f changes from negative to positive. So we have here at this point -4 again. So we can test -4. And we also have nowhere else. We don't have any other point where f changes from negative to positive. Because here it doesn't change signs, it just goes to 0 and stays positive. And then here it changes from positive to negative. So this is the only other point we have to test. So first let's test g of -5. So all we have to do is plug -5 into g. So that's going to be equal to -3 to -5 of f of t dt. So -3 to -5, we can't do that because the b value is greater, or is less, than the a value. So what we have to do is flip it, make it -5 to -3 f of t dt, and then make it negative. So all this is asking for is the area under the curve of f from -5 to 3. So from -5 here up to, or to -3, sorry. And this triangle right here and this triangle right here are the same area, right? They're both 1/3 and 1/3, but one's negative, so they're going to cancel each other out, and this is going to end up being equal to 0. So now I'm going to kind of get rid of this work so that we have more space, but I'm going to remember that g of -5 is equal to 0. So now g of 4, we're repeating the process, -3 to 4 f of t dt. So now we have to find the area from -3 all the way up to +4, or the area under the curve from -3 up to +4 of f of t. And that's equal to, so for the first thing I notice is that this triangle and this triangle are equal, but one's positive, one's negative, so we don't have to worry about that portion. And then we have to find this area, do it in green. We have to find this area. So what I said in the start was these two cancel. We have to find that little area under that semicircle, and then we also have to find the area of this rectangle and this triangle. So let's start with the rectangle and the triangle. The rectangle is 3 times 1 is 3, plus the triangle is 3 times 1 over 2, so 3 over 2. And then we're also going to add the area under this little circle. So the way we're going to do that is take the area of the full rectangle, which is 2 times 1, so we're going to go 2, minus the area of the semicircle, because that's above the curve. We're trying to find the area under the curve. So if the area of a circle is pi r squared, and we have a radius of 1, the area of this full circle is just pi. So if we're dividing it by 2, we're going to have 2, this full rectangle, minus this area, which is pi over 2. And for the sake of the FRQ, you can leave it like this. You don't need to simplify it out, but I think it would be better and easier to understand if we simplify it a little. So let's make that into 6 over 2. So we have 9 over 2 plus 2 minus pi over 2. And 2 is equal to 4 over 2. So we can do 13 over 2 minus pi over 2. And I think that's right. I'm not very good at addition or subtraction, but that should be all right. I apologize, I accidentally wrote behind the face cam there, so you couldn't really see the number, but I have it written here. And something I immediately notice, now that I have these two values next to each other, and we're trying to find, and I know that we're trying to find the absolute minimum, I know that this is not a candidate, so it can't be, 4 can't be the x value where the absolute minimum occurs, because this number is greater than 0, because it's about 13 divided by 2, let's just say 7, minus 3, about 3 divided by 2 is obviously a positive number. So this is not, it's no longer a candidate for the absolute minimum of g. So now let's find g of -4, the last value that we need to find. We're going to repeat the same process. We're going to plug -4 into the function g. We're going to have the integral from -3 to -4 of f of t dt, but that's not possible because b is smaller than a. So we're going to flip it and make it -4 to -3, and then make it negative f of t dt again. And now what that's equal to is the area under the curve from -4 to -3. So this is it's just one little triangle. 1 times 3 over 2 is just 3 over 2, but remember it's negative. So -3 over 2 is our final value. And looking at all these three values, -3 over 2 is less than this because this is greater than 0, and -3 over 2 is also less than 0. So 0 or g of -5 can no longer be the absolute minimum value. So we know that the absolute minimum value of g occurs at at x equals -4. Sorry. So what we're going to write for our final answer is, I'll write this in black, I guess. The absolute minimum value of g. Once again, I'm kind of repeating the words from the question to make sure I'm answering the right thing. So the absolute minimum value of g on the closed interval, right? We're going to continue repeating their words. On the closed interval, -5. Make sure we use these kind of brackets because it's a closed interval. -5 to 4. And then I forget to use the brackets. Oops. A closed interval -5 to 4 is -3 over 2, right? We're using this number right here. But the reason we're using -3 over 2 and not -4 is because it's not asking for the x value, it's asking for the absolute minimum value. So if you have a function g that kind of goes like that, whatever, and you're asked for the minimum value, you're not going to give the x value at which the minimum value occurs. You're going to give the actual output what that minimum value is. So that's why we're using -3 over 2 and not -4. But anyways, so it asks us find the absolute minimum value of g on the closed interval -5 to 4. So the absolute minimum value of g on the closed interval -5 to 4 is -3 over 2, and then it says justify your answer. So the way we justify that answer is -3 over 2 because g prime of -4, or the point at which it occurs, changes from negative to positive. So therefore it's a candidate for the absolute minimum. And because it's implied though, so you can just write and, g of -5 and g of 4 are both greater than g of -4. So we explained that the absolute minimum value of g on the closed interval is -3 over 2. We said that's because g prime of -4 changes from negative to positive, meaning -4 is a candidate for being the absolute minimum because it's a relative minimum, and because both of the endpoints are greater than g of -4. Therefore, we're explaining how we use the MVT, or the EVT, sorry, to figure out that -3/2 is actually the absolute minimum value of the graph of g on this given interval. Okay, C is done. Now we can look at part D. So part D is a little more of a brain teaser. You have to think about it a little more, but it's still very doable. So it asks us to find the values of x in the open interval -5 to 4, meaning not including the endpoints, because it's an open interval, at which the graph of g has a point of inflection. So let's think about that for a second. If g has a point of inflection, that means g double prime changes sign. Meaning if this is the graph of g and it changes from concave up to concave down at this point, on the graph of g double prime, it's going to change from, see, concave up to concave down, it's going to change from positive to negative. So these 2 points are essentially equivalent. So what we can do with that information is we can find where g double prime changes sign. So first, let's find what g double prime actually is. So let's start with what we already know, which is g prime is equal to f. And then if we take the derivative one more time, I'll do that in green, we're going to have g double prime is equal to f prime. So now the question becomes, instead of find the values of x in the open interval -5 to 4 at which the graph of g has a point of inflection, we just altered the question, made it easier to understand by changing it to find all the values of x in the open interval -5 to 4 at which the graph of f prime changes sign. And if f prime is changing sign, right, if it's changing from positive to negative, say this is our axis, if f prime is changing from positive to negative, like at this point here, what that means is that on the graph of f, it's changing from increasing to decreasing, or it's changing from decreasing to increasing. That's the equivalent of this point here, f prime changing sign. So now what we can do with that information, that understanding, is go back and look at our graph and find where does f prime change sign, or where does the graph of x change from increasing to decreasing, or decreasing to increasing. So the first point I noticed is right here, because f is increasing, or f prime is positive, and then f is decreasing, or f prime is negative. Next we can look at this point, but this point does not fulfill what we want, because f prime changes from negative and it stays negative. So it's negative, it's decreasing, and it's still decreasing. And then at this point here, f prime is negative because it's decreasing, and then it changes to positive because it's increasing. Sorry about that, my dog was barking at the mailman, but anyways, so this point, whoops, I'm gonna do that. This point right here, f changes from decreasing to increasing, or f prime changes sign from negative to positive. So that's another point that we can use. And at this point right here, f changes from increasing to decreasing, or f prime changes sign from positive to negative. So that's another point we can use. So for our final answer for D, find all the values of x, so now it's asking for the x values, on the open interval -5 to 4 at which the graph of g has a POI, or point of inflection, we can write x equals -3, 1, and 2. But notice how it doesn't include justify your answer like parts B and C do. It's not included. So we can just write x equals -3, 1, and 2. And that's it. That's our final answer. Thank you very much for watching, and I hope that you would, if you enjoyed the video, you would like or subscribe. And I hope also that you would show your friends these videos if they need help in their calculus class. And also make sure to comment if you would like to request any kind of video, if you comment and request a video, there's about a 99% chance that I will make that video. So thanks again for watching, and please like and subscribe.